Welcome to Study Loop.
So we know that we have a runner and he's sprinting around a circular track at a constant speed of 7 meters per second. So we have a person right here running around at 7 meters per second. Then another thing we want to keep in mind is the fact that this has a radius of 100 meters. So this is also going to be 100 meters. Then we have their runner's friend standing at a different distance of 200 meters from the center. So then we have another 100 right here. And the friend. And we want to know how fast is the distance between the friend changing when the distance between them is 200 meters. So we want to know that when this is the case, right here, when this is 200 meters, what is that rate of change? And we have an angle right here, and that's going to become important. So with this in mind, we want to draw this diagram that'll help us somewhat. Then we want to relate our quantities using the cosine law because we have a lot of sines and one angle. So we see that c squared, which is this, c is going to be the distance. So c squared is equal to a squared plus b squared minus 2ab cosine theta. So using the law of cosines and differentiating both sides, we get that 2c dc dt equals 2ab sine theta d theta dt. Solving for dc dt, in order to do that, we need to find sine theta and d theta dt. So because it's not given to us, we're going to have to find it ourselves. So since the runner is moving at 7 meters per second, we want to relate that to the arc length formula, which tells us that the radius times theta is equal to the length. So differentiating both sides again, we'll get that dr dt theta, and this is chain rule, plus r d theta dt is equal to dl dt. When we rearrange our values and plug in the ones that we know that dl dt is 7 over 100. So we have 7 over 100, and then we know that that is equal to d theta over dt. So that's 0.07 radians per second. So with this in mind, we now need to find theta. So we'll go back to our cosine law and plug in important values. So we'll have that the cosine of theta is equal to c squared minus b squared minus a squared over 2ab. And when we plug in the values that we know for a, b, and c, based on our diagram up here, we end up getting that the cosine of theta is 1/4. And then we could solve for theta, or we could use the Pythagorean identities, which tells us that the sine squared of theta plus the cosine squared of theta is equal to 1. So just solving this way, we get that the sine of theta is equal to root 15 over 4. So with all these values now, we go back to what we had originally, which is when we solve for dc dt. And what we end up getting is this is going to be ab sine theta d theta dt all over c. Plugging in these values that we've already solved for and that were given, we get that dc dt is 7 root 15 over 4, which means that when the distance between the runner and his friend is 200 meters, they're changing at a distance of 7 times the root 15 over 4 meters per second.